Let's talk about the discriminant of quadratic equations and how the discriminant tells how many solutions the equation has. Well, the discriminant is the number which is inside the square root. It can be denoted, for example, by letter capital D or by delta. We have that if this number D is larger than 0, we have two solutions, x1 and x2. That's because the plus minus sign and the positive number after that will create these two different solutions. On the other hand, if the discriminant would be 0, then the square root would disappear. Square root of 0 is 0. So we would just get one solution, x is equal to minus b over 2a. On the other hand, if the discriminant would be negative, we don't have any real solutions. That's because for a negative number, a square root is not a real number. In this video, let's have examples of all the possible cases. Let's consider this equation. We have the coefficients a equal to 1, b equal to 1 and c equal to minus 2. And if we calculate the discriminant, it was b squared minus 4ac. In this case, it is 1 squared minus 4 times 1 times minus 2, which gives 9. This is a positive number. For this polynomial, we have two solutions, 1 and minus 2. And the graph of the polynomial looks like this. If we draw the axis and the points 1 and minus 2 in the x-axis, the polynomial goes like this. Let's have another example. Let's take a polynomial x squared plus x minus 2 plus 9 over 4. Here's the polynomial simplified, and how is the discriminant? We have that now b is again 1, we have 1 squared minus 4 times a is 1, so 1 times 1 over 4. And we get minus 1, which is 0. Now what happens here? We have taken this polynomial and we have added something positive there. So if we would now draw the graph of the polynomial has shifted up by this amount, and now it happens that the graph of the polynomial touches the x-axis exactly in 1 point. And what is that point? Now the square root term vanishes and we have minus 1 over 2 times 1, because b is 1, a is 1, that's minus 1/2. So the equation has just one solution, x is equal to minus 1/2. We can find the point here. Let's still have a third example. Maybe we take our equation like this. Now we have shifted the graph of the polynomial still up, and it will happen that the graph won't touch the x-axis at all. Well, how to see this by using the discriminant? B is 1, we have 1 squared, minus 4 times 1 times 10. We have 1 minus 40, which is minus 39. That's negative. Because the discriminant is negative, the equation has no real solutions. So, in conclusion, second degree equation can have two solutions, just one solution, or no real solutions. And these facts can be discovered from the discriminant, which is positive, 0, or negative.